if I was going to do the cube root, again, now I'm looking into groups of 3's of numbers. So I could take 3 times 3 times 3, x times x times x. And therefore, the cube root of 3 times 3 times 3 is 3. The cube root of x times x times x is x. And therefore, what's left after has to remain under my radical, which is 2xy squared. Everyone OK with that? Now, the other way I could do that is now, if you guys remember, I said I like taking the term of cube numbers, right? Taking the cube root of cube numbers. You can do the factorization and then take out the groups of 3. I like doing it, though, as cube numbers. So to do that, though, we have to know what our cube numbers are. So Sierra, when looking at the cube numbers, square numbers are numbers multiplied by themselves. Cube numbers are numbers multiplied by themselves 3 times. So Mariana, when I'm looking at the cube numbers, the first cube number, 2 times 2 times 2, would give me 8. 3 times 3 times 3 gives me 27. 4 times 4 times 4 gives me 64. And 5 times 5 times 5 gives me 125. I would highly recommend knowing those square numbers as square numbers and knowing those cube numbers as your cube numbers. So I look at this and I say, can I rewrite any of these numbers as a product to give me 54? Yes. You could do 27 times 2. Then, can I write x to the 4th as some number, as x raised to the 3rd power as a product to give me x to the 4th? Yes, you can write it as x to the 3rd times x. Right? Because what's x to the 3rd times x? X to the 4th. And then we still have y squared here. So now I know I can take the cube root of 27. That's just going to give me 3. The cube root of x cubed is just going to leave me with x, leaving me with the cube root of 2xy squared, which is the same answer that I got before. Mariana, you need to turn that over, please.